And here are a couple basic properties, and they're very easy to prove. Here, I don't want to waste a lot of time proving it, proving these. Proving these equalities, right? Here, the first one actually somehow I proved it, right? That is, sine and cosine are complementary of each other. Sine 90 degree minus theta is equal to cosine theta, and cosine 90 degree minus theta is equal to sine theta. And here, I don't want to get into tangent, cotangent, and secant and cosecant. And here, you will know that. So this is a property actually we just used for that problem. That Irene emailed me that. And if you know this property, actually that would take you 1 second or half a second to solve that problem, and the time saved can be reserved for other challenging problems, right? And also, my recommendation would be for you to memorize, seriously, to memorize this table. That is, you got to memorize. If you want a table from me, I can send it to you upon request. Okay, or you can Google. It's everywhere, and it should be in your textbook if you're a high schooler. So for 90 degrees, how to express the radians, 30 degree, 45 degree, 60 degree, 90 degree. Usually these are about it. And it goes on. Multiples of 30 degree, 45 degrees, and 60 degrees, and 90 degrees. And there's a pattern here. I can only vaguely recollect because that's what I learned in high school too. And I don't have photographic memory here. But as far as I know, these are the numbers. If you can memorize, would greatly facilitate the process of solving problems. Okay, so for some problems you would spend, let's say, 1 second. Others probably have to spend 1 minute. So yeah, my recommendation: memorize. And there's a pattern here, actually here. Anyone can see the pattern here for sine? Anyone here? Do you have you recognized any pattern here, just to quickly memorize these numbers? Austin.
Well, the pattern for sine.
Yeah.
So
0 degree, 30 degree, 45 degree, 60 degree, 90 degree, and see these numbers. So here, I'm trying to help you memorize these numbers.
As it goes across, it's like the square root. Like sine of 30 degrees is square root of 1/2. Sine of 45 is square root of 2/2, and then it's square root of 3/2, and sine 90 is square root of 4/2.
Very good, very good. Basically, the numerator actually goes up by square root of 1 unit, right? So here is square root of 0/2, right? Do you agree for 0? If we have to do it. Austin, do you agree?
Yeah.
So for 30 degree is square root of 1/2, right? For 45 degree is square root of 2/2. And 60 degrees is square root of 3/2. And 90 degree is square root of 4/2. You see that? And cosine actually reverse that pattern. Reverse that pattern. And here, Grace, can you recognize any pattern here for tangent?
No.
Give you a couple more seconds. Anyone here? Because I just figured out actually a couple of weeks ago, because I was like, this number is pretty hard to memorize, right? Do you agree? And so I was closely reading these numbers, and then, wow, actually there was a pattern here. Grace? Yes. Okay, here. Yeah, Grace, do you have any thoughts about it?
No, I have no clue.
Oh, yeah, that's fine. That's fine. Anyone here has any clue? it's pretty hard actually. Yeah, Edward, yeah, that's right. You got it. So it's basically it goes by a multiple of square root of 3. So this is yeah, I would say except the first one. So this is square root of 3 over 3, right? This is square root um, multiplied by square root of 3. This is squared square root of 3 over 3. So that's 1, right? Do you see that? So this one is a multiple of square root of 3 of this one. And this one, again, is a square root of 3, is a multiple square root of 3 of this one. You see that? Increased by a factor of square root of 3. You see that? But not this one. Okay, so I guess probably I have to apologize. I didn't speak very clearly about it. But why this number does not fall under that pattern is probably because this one is undefined, actually. Okay, and I want you to think about it. Why this is undefined? Why this is undefined? Why 90 degrees? We want to calculate the ratio of the opposite over adjacent. It is undefined. I want you to think about it. And okay, yeah, okay. So that concludes my discussion about trigonometry. Pretty much.